In this video, I want to do a couple of things. First of all, I want to model how to really use your problem journal to work problems and my expectations around that. And then also, we're going to actually work on this topic, writing single variable equations. And so I'm going to write that here at the top. In my problem journal, every entry should have a title. And today we are writing single variable equations. And the date is the 18th of September. So I'll also date my journal entry. And I'm working a problem from our class slide deck. And you know, a lot of people, they don't want to waste their lives copying things down. But in the problem journal, it's really important that what we do here stands alone, in the sense that I could open up to this page and I could show somebody my work, and I wouldn't have to go digging through the slides to let them know which problem I was actually solving. So I'm actually going to take a few seconds to write down the problem, which is this problem. Anne is 12 years older than Nan. And Fran is twice as old as Anne. Okay? And the sum of their ages, is 68. How old is each sister? Question. And the strategy that I'm going to introduce here, maybe you could reason this out and scribble some stuff down and figure out the age of each sister. It's not an extremely difficult problem, but I want to introduce a way of organizing your work that can be very helpful when we have more challenging problems that we have to write equations to represent. So I'm going to begin, and I'm going to make a table. And I call this a guess and check table because before we ever learn the various strategies for solving an equation, we want to learn how to actually take information like this and write an equation. And that starts with a guess and check table. And when we make a guess and check table, the first thing we need to think about is, what are we going to guess? And we got three sisters here. We could guess any one of their ages. They all depend on one another. But I want to just point out that Fran's age, because they told us that Fran is twice as old as Anne, we know that Fran's age depends on Anne's age. And then from the first sentence, Anne is 12 years older than Nan. So we know that Anne's age depends on Nan's age. So if I guess Nan's age, or if I know Nan's age, I can figure out Anne, and then I can figure out Fran. So I'm going to start my table by guessing Nan's age. So I write that, guess Nan. And my table, I'm going to extend it all the way across the page here. I don't know how many columns I'm going to need just yet, so I'm not going to make a bunch of columns. I just made one column. And I know that if I just guess that Nan is 10, then I can figure out pretty quickly by adding 12 that Anne must be 22. And if Anne is 22, I can multiply that by 2 to get Fran's age. She is got to be 44 if Anne is 22. And then I want to see if I'm right. And the way I'm going to check and see is if I add up all their ages, if I find the sum, I should get 68. So when I add these up, I get 44, 54, 64, 66, 76. And obviously that's not right. But before I go on, I just want to do one more thing. I want to make it clear what I'm doing. I'm checking if the sum equals 68. And I like to put a question mark there. Does the sum equal 68? Well, it doesn't. It's too high. So let me revise my guess. And now, instead of 10, I'm just going to go down and I'm going to guess 8. And you all are pretty smart, so you probably figured out that if Nan is 8, then Anne has to be 20, and Fran has to be 40, And that adds up to 68, which is just right. So I got my solution. But I haven't written an equation yet. I know how old these three sisters are, but in order to write an equation that represents that, I'm going to extend my columns just by one more row. And instead of guessing a number for Nan's age, I'm going to guess a variable, n. Well, if Nan is n years old and Ann is 12 years older, then Ann has got to be n plus 12 years old. And then Fran is twice Ann's age. So I'm going to multiply Ann's entire age, this whole little expression, times 2. And now I've got 3 ages in terms of n. And if I add them together, n plus 12 plus 2 times the quantity n plus 12, that should equal 68. And so now I've written an equation with a single variable that represents the relationship between all the information that was given to me in the problem. And notice we're using, in our last unit, we wrote algebraic expressions. And that's what I did right here to represent their different ages. And when I added them all together, I wrote another algebraic expression by combining these three as a sum. And I'm going to continue working with this expression. I know that it should equal 68, but let me just simplify it a little bit. First, by using the distributive property. And again, that should still equal 68. And then I'm going to combine like terms. 1n, 2n's, 3, 4n's all together. Plus 12 and 24 make 36. And again, that should still equal 68. And one of the things that we're also going to be doing in this unit is solving equations like this, and of course more challenging. And this is probably something that you've seen before. But I'm just going to introduce kind of informally what allows us to do this. I would like to subtract this 36 from this expression. And that would just leave the 4n all by itself. But I can't just change my expression however I like. But when we have an equation, what we're saying is these two expressions are equal. And what the properties of equality allow us to do, that if we do something to the left side of this equation and we do the same thing to the right side of the equation, then the result, again, notice I'm operating on either side of this equation, the result is another equation that still holds true. 68 minus 36, that is 32. So this equation is a little bit simpler, but it should still be true because I used the property, the subtractive property of equality to just subtract 36 from both sides of this equation, and I'm left with this. Now I can do the same thing if I want to divide this side by 4 so that I'm left with just an n all by itself, 1n. Well, let me divide this side by 4, and I'm left with n equals 8, just as we expected. And so we can use the strategy of guessing and checking to solve this problem. And if we're organized and we set up our table, we can use our table to write an equation and then solve that equation. But remember, the question is asking us how old is each sister. So I want to just finish off by saying Nan is 8, Ann, 12 years older than that, is 20. And Fran is twice as old as Ann, which is 40. And that is my solution.